afternoon, everybody, and welcome to our Thought Leadership event series showcasing research aligned with the United Nations Sustainable Development Goals, which explores the outstanding work of Western researchers. Western Sydney University is proud to be ranked globally in the Times Higher Education University Impact Rankings for sustainability since 2022, reflecting our ongoing commitment. This series forms part of the Western Sydney University's Sustainability and Resilience Decadal Strategy 2030. Join us to explore CO2 Concrete, an innovative approach that transforms construction and demolition waste into high-performance, low-carbon concrete. By injecting CO2 into recycled aggregates, the process strengthens materials, improves performance, and permanently stores carbon, supporting more sustainable construction. Let me introduce our speakers of the day. Distinguished Professor Vivian Tam. Distinguished Professor Vivian Tam is a world-leading researcher in construction engineering and management, internationally recognized for advancing green building practices and recycled concrete solutions to address climate change. Professor Tam is the director of the ARC Industrial Transformation Training Center for Digital Platforms, Net Zero Building Ecosystem Life Cycle, also known as NOBLE, at Western Sydney University. Professor Tam has published more than 330 refereed journal articles with over 42,000 citations, has held 9 ARC-funded projects, and serves as editor-in-chief of the International Journal of Construction Management. Professor Tam's accolades include the 2025 New South Wales Premier's Prize for Excellence in Engineering or ICT and recognition among the world's top 2% of scientists since 2017. Ms. Lourdes Sanchez is National Technical Manager, Aggregates, New South Wales and ACT at Holcim, Australia. A civil engineer with nearly 30 years of experience, they specializes in concrete, aggregates and cement applications. Mrs. Sanchez began their career with Holcim Spain in 1998, leading quality assurance, mixed design and control across multiple business units, and relocated to Australia in 2013 to head technical services for New South Wales and ACT, and has contributed to some of the state's most transformative infrastructure projects, including Northwest Rail Link, WestConnex, Sydney Metro projects, the M7, M12 integration, and the CBD Light Rail. They now focuses on advancing low-carbon concrete solutions for a more sustainable future. Our next speaker is Ms. Saji Srivelan, who is the Sustainability Manager for the Parramatta Light Rail Stage 2 Enabling Work Project, Transport for New South Wales' first infrastructure sustainability V2.1 project. A graduate in chemical engineering and pharmaceutical science, Ms. Srivelan brings extensive experience delivering sustainability outcomes on major infrastructure projects across New South Wales and Victoria. Their portfolio includes the Melbourne Metro Tunnel Project, level crossing removal projects, and the Upper South Creek Advanced Water Recycling Centre and Pipelines, John Holland's first IS V2.1 project. A warm welcome to all of you for this number 7 Thought Leadership Event Series in 2026 and number 43 since 2022. And over to you for the presentations, followed by a panel discussion. Starting again.
Thanks very much for the introductions, and I'm really glad to be a part of the Thought Leadership event as well. But where can I stand to see? Oh, okay, here. Sure, okay, here. I can manage it. I'll introduce the CO2 concrete with you today. First of all, let me introduce myself a little bit. I have a research interest of sustainable constructions and focusing on green building, life cycle analysis, and particularly today, I want to talk about recycled concrete. I'm currently also the editor-in-chief of the International Journal of Construction Management, a bit of a research funding that has been introduced in here. You can also see my research outcomes and research impact just for your information. First of all, I want to let you know the way I'm coming from. Since I was an undergraduate student, I started doing research. I was first looking into environmental management, packaging on waste management. specific on the management perspective on the waste component. When I move it to PhD, I actually move it to the waste recycling, a bit more tap in there, and the targeting on recycled concrete, and also looking into mixed recycled materials as well. In the last 10 years, I'm also looking into green building components, looking into how can we achieve the green building in an effective way in a multiple input and multiple output system. So my simple term is like a contractors or a client that they want to build a 6-star green star building. But I will tell you, okay, you want green star, that's the output that you want. I will tell you how to make it. Give me the heat input. Or we tell me, okay, you have these kind of materials and I put into the system and I will tell you how much you can achieve in terms of the life cycle performance. That's the input output is a two ways. And of course, as I mentioned, that I'm also looking into life cycle assessment with my management background. I want to ensure that whatever materials or whatever products that we're develop is ensured that in achieving the long-term perspective, not about cost, but also the carbon as well. My overall research I'm looking into is the middle one, is the sustainable construction management and engineering. Today, I want to talk specific about concrete. Hopefully, we bring low carbon concrete and recycled aggregate together. One of you know what is low carbon concrete, which is kind of like a way common term the majority of our concreters or concrete experts will know well, which in the simple term low carbon concrete, mostly they are reducing the cement quantities. That means we're using cement substitute materials. But what if we're also looking into the majority of the volume component, because aggregate is occupying more than 80% of the volume. And what if we bring these two together? And what if concrete could also reduce the embodied carbon, embrace the circular solutions, reduce the emissions, and permanently sequential the carbon emissions as well? That's why I want to introduce CO2 concrete in here. CO2 concrete is a new durable high-strength recycled concrete. We have invented CO2 concrete as a new process. How exactly we are doing is we inject carbon dioxide into the recycled aggregate to improve its bonding and also the performance, the overall performance of the recycled concrete. I have a, here, you can also see that it's a one solution, but bringing endless benefits. We bring the circular perspective. The only about one circle of recycling is circular. That means you recycle and recycle again. That means you turn waste into valuable materials continuously. Obviously, we are reducing our carbon by permanently capture and store the carbon emission in the concrete. And we're not only improving the recyclability, but we also add value by upcycle the waste as well. Not classify waste as waste, we improve the waste as its best value. I had a 90 seconds video that we created under the Holcim Accelerator program. I want to share with you on what CO2 concrete is.
The world is in a race to reduce the amount of human-induced carbon being emitted into the atmosphere. One of the biggest emitters of carbon is concrete. After water, concrete is the most widely used substance on the planet. In just the time it took to get to this point of the video, 19,000 bathtubs of concrete have been poured. Traditionally, when a building is demolished, the old concrete is never repurposed, making its way to landfill. What if there was a way of not only recycling the concrete, but also using the concrete as a vehicle to capture and store carbon created during the manufacturing process? Introducing CO2 concrete, a revolutionary new durable high-strength carbon capture concrete that uses recycled aggregates in conjunction with low-carbon concrete. These treated recycled aggregates are fed into a chamber where they are injected with CO2, which not only improves the quality of the aggregate, but also its performance. The CO2 treated aggregates are then taken to a concrete plant to be used in the final concrete mix. The result is a more sustainable building with a reduced carbon footprint. This is a truly circular economy solution that turns construction waste into recycled materials without compromising performance. CO2 concrete.
Okay, that's a short introductions about what CO2 concrete is. I also want to acknowledge Holcim Accelerator program that is helping us to develop this as well. In here also you can see that I showed a little bit of technical information in here. this is what virgin concrete, and this is the percentage of CO2 aggregate injected at up to the 100% CO2 concrete. If we purely by replacing recycled aggregate to virgin aggregate, the strength actually go down by about 30%. But if we injecting carbon dioxide into the recycled aggregate, the strength go down and similar as the virgin concrete performance. Not only the strength is matching, but also the cost as well. In a one similar calculation on that is roughly about $300 per cubic meters with a virgin concrete. Recycled aggregate is lower price than virgin concrete. The cost did go down, but the strength also go down. That's why limit its applications. But we inject carbon dioxide, the cost is increasing a little bit, but it's still about 10% cost reduction compared to virgin concrete. This research has been done in the laboratory over the last 10 years. In the recent years that we have attended different kind of accelerator program or commercialization program, we are very glad that we previously did a few polls within the university. And very glad that in 2022, we are selected as the Australian winner under the Holcim Accelerator program. And that's why we had the first mission. Everyone was saying that we had to put the concrete outside the university. That's why that's one of the 3 missions that we are under the Holcim Accelerator program is to put it as a commercial port. And we made it. We are managed to, in October 2022, we are managed to have the first commercial port at Black County Homing Center. I have a real concrete that we brought on the day is in here as well. It's the first one. And after 1 year, although the program was done in 2022, but the relationship hasn't finished. We continue try to put out the second slabs as well. And just to go back a little bit, the last pause we done there is a 40% replacement, 30% replacement, 40% replacement ratio because of the international standard is 30%. That's why the last one pushed to 40, and this one will push to 50%. And we are called that is the Emerson Park North Community Car Park. It's under the similar partnership with Holcim. And these are our slabs, and the middle one is our real concrete made like Emerson Park as well. And the third one, although after 2 commercial ports that we both did in New South Wales, and we think we have John Holland coming and said that, hey, how about let's try outside New South Wales? I say, why not? And we have the relationship, and again, because of the last 2 ports already 40 and 50%, we have to push it higher. Otherwise, there's no point for me to keep the same ratio. And we managed to break through a few challenges. It's really challenges to break through the percentage. As you can imagine, the international standard is only 30%, and we push it to 40, 50 already. And now we want to push it to 60. After multiple tests and multiple discussions and different kind of argument in a way, we managed to make it to 60% in Victoria, and it's at the Maidstone Train Maintenance Facilities in March last year. And this is what we have. And we also pour some cylinders back from Melbourne back to Sydney as well to do some further tests. And the third one is in here. There's 1, 2, 3. Basically, you can come and touch it later. There's nothing different from any other concrete. And this is our concrete webpage. Feel free to explore it. We not only have the commercial details, we also have all our published materials and also our awards as well. It's at co2concrete.com.au. This is our journey so far. You can see that we start more than 10 years ago, and we actually joined a couple of accelerator programs. In 2017, we were one of the top 8 finalists in Innovi's Waste Tech program. It was the first time that they trained me as a businesswoman, if I can say that. They telling me all the terms that I have never learned about, which is quite an interesting perspective. And then we continue our research, and in 2022, as I mentioned, we are the Australian winner of the Holcim program, and we done 3 slabs, and what we are aiming. And then we also had last year, we also joined the CSRO on-prime programs as well. And what we are really aiming is we have awarded an AEA grant early this year. That's why we're really aiming to further accelerate and then further developing as well. In here, I want to share a 2-minute journey video before I pass it to my partners.
The world is in a race to reduce the amount of human-induced carbon being emitted into the atmosphere. One of the biggest emitters of carbon is concrete after water. Concrete is the most widely used substance on the planet. In fact, every second, 19,000 bathtubs can be filled by the poured concrete globally. Traditionally, when a building is demolished, the old concrete is never repurposed, making its way to landfill. What if there was a way of not only recycling the concrete, but also using the concrete as a vehicle to capture and store carbon created during the manufacturing process? Introducing CO2 concrete. A revolutionary new, durable, high-strength carbon capture concrete that uses recycled aggregates in conjunction with low-carbon concrete. These treated recycled aggregates are fed into a chamber, where they are injected with CO2, which not only improves the quality of the aggregate, but also its performance. The CO2-treated aggregates are then taken to a concrete plant to be used in the final concrete mix. This is a circular economy solution that transforms construction waste into recyclable material without compromising performance. The carbonation process is not publicly available due to confidential agreement. The journey of CO2 concrete has been marked by continuous progress and breakthrough innovation. The first successful pour was completed on October 26, 2022, at the Blacktown Animal Rehoming Centre in Sydney. A 27 by 2 metre slab, using 40% carbonated aggregate, the pour was carried out in partnership with Holcim, A.W. Edwards, Bouygues, Sika and Mark McDonald. The second was on October 31, 2023, at Edmondson Park North Commuter Car Park. A 25-metre pathway was poured with 50% carbonated aggregate with support from Holcim, A.W. Edwards, Transport for NSW, Liverpool City Council, and Western Sydney University. The third took place on March 12, 2025, at Maidstone Tram Maintenance Facility in Victoria, in collaboration with Heidelberg Materials, Alex Fraser, and the Northwestern Program Alliance. This 25-metre pathway reached a 60% replacement rate, our highest yet. Each pour builds momentum, pushing CO2 concrete closer to mainstream adoption. Looking ahead, we will continue to promote this product, working closely with government to ensure that the implementation of innovative solutions strengthens industry demand. With collective effort, we believe every step we take brings us closer to building a better and cleaner Australia.
Great. That's the journey that we have so far and the partnership that we have as well. And that is the end. I'll bring it back to the chair. Thank you.
Next person, please, Ms. Lourdes Sanchez, please.
Thank you. Hey, well, thank you so much for having us. It is absolutely a pleasure to be part of this exciting journey. Before we start, I'm going to introduce a little bit what is Holcim and our company. Okay. I think that is not presentation. So it's a PDF. Yeah, and I put in I never read it. Okay. Do you want to like? No, that's okay. Yeah. I can move. Yeah. Okay. They were taking but like the passive but that makes it. Okay. Hopefully, yeah, you can see the slide, but Holcim is it's an international company with more than 45,000 employees across more than 40 countries on the 5 continents, and with sustainability as the core of our strategy. We are becoming a net zero company with clear net zero target validated by science-based. Thank you. Validated by the Science-Based Target Initiative. We are driving circular construction as a world leader in recycling with more than 30 live projects to recycle CO2 from our operations.
We are dedicated to being, the front of innovation with 6 R&D centers across the globe, more than 300 patents in green construction, and more than 100 startups in our open innovation ecosystem, and more than 40 partnerships with some of the best academic institutions in the world, including the LCE, Western Sydney, Europe. So let's go through a little bit our journey about sustainability in Australia and our journey. Can you hear me? Our journey started in 2019. That it was the first time that concrete manufacturer company have EPDs available for our products. So we were, the first through EPDs Australasia. And then in 2020, we also have, the first process for EPD certification in Australia. That's give us the opportunity to offer EPDs on demand for projects that specifically needs EPDs for the range of the, the product used in any specific project. So that it was almost 6 years ago now. In 2021, our journey about low carbon solution came on board, and we launched our global low carbon brand, EcoPact. So that is, I'm going to discuss a little further about EcoPact, but the next one was developed also EcoPact Active. This is our high performance range when early strength requirements are necessary, and then low shrinkage limits. So that is also available. In 2024 also we have the Global Green Tag product health and declaration that also will help us to to have a higher responsible value proposition. And just recently, I'm really excited to share with you, just a month ago, we in 1st of June, we launched our, it's a label, it's a global, Holcim global label, EcoCycle, that is basically, it's a validation that the product contain minimum 10% of construction demolition materials, and this is also verified by a third party, by ISO. So that is our journey so far. And early, to give a little context, is construction, as you know, basically represents more than, the numbers can vary, but more than 30%. I think it's a fair number of the total emissions. So that's, we are responsible for more than 30% of the total emissions. In terms of the, globally, obviously construction is, consumes a lot of building materials, so around 30%. Biodiversity loss, so that is also something to consider. And unfortunately, just, around 7% of the, big number, more than 100 billion tons of raw material are recycled. So that is, this is the reason that also some of the Holcim pillars are aligned to these 3 necessities. And the first one is one Holcim pillar is climate, and that is where really our range of product try to address some of the items that I mentioned before. And this is where, internal product, we have the low carbon solution and EcoPact. We have also decorative for some application, it's your stone. We have Dynamax. We have products that basically align to these necessities, and they also are validated by EPDs or supported
tests and evidence that basically that is is going to assist this reduction. And then also we have no recently, but we have future cast. This is our low carbon solution for precast application as well for fumes. But probably talking about concrete, and I think we are going to discuss much more about concrete. Is I would like to explain a little bit more what EcoPack is. It's a brand. As as I mentioned before, we launched around 5 years ago in a small range, normal class, and this range is building as soon as the request and the necessities come to us. And what is EcoPack is minimum with certified minimum 30% embodied carbon reduction from, is important, compared with what, is from the LCI reference, and then also is validated by EPD. So this is what EcoPack is, and at the moment, well, our goal is, is to have more than 50% of our volume around the world in 2030 should be low carbon concrete. So this is a challenge, but we are moving in this direction. So quite exciting. Also aligned to low carbon, we need to probably think a little bit more what else we can do. And then also we have a range of what we call digital solution that help us basically to address some of these challenges that all these initiatives are going to bring to our day by day, probably more for our customer and construction. And that is Smart Flow is a system that basically gives us the chance to assess and model and reproduce how this mix is going to be able really to pump on site. This is pumpability and rheology is one of the main challenges that we have been facing, with the probably with some high replacement or alternative materials. So we are able really to to predict when we compare with different reference how this mix is going to performs in the field, exactly matching your setup. We are able really to, this is the pump, this is the number of elbows that you have. So this is a Smart Flow. Very, very good solution, basically to probably to prove some of the concern that can come from our customer. And then a Smart Cast is a real, when we are talking about early strength requirement, a Smart Cast is going to help basically to modeling what is happening on site, knowing a small cylinder with, a few liters, is what is happening really on site through the maturity system. And Smart Them is also one of the sort of initiatives that help us to monitoring the peak temperature. This is also some of the challenge on site. So that is about the first pillar. The second one is circularity. So talking about product and the same strategy, we also have two different ranges, and I'm talking about concrete, but we had to bring now aggregate on board as well, because we have also a range of aggregate with recycled material for road base, for different application. We are working with different, we also are able really to produce recycled aggregate in our quarries or engage a third party basically to ensure that this the raw material is available. And this is new. And then in terms of the, now the new initiative is with EcoCycle, on board. And obviously, this is aligned to EcoPack. So EcoPack with EcoCycle inside is also one of the solutions. We are working, what this is really exciting about what is happening nowadays in terms of sustainability. And there is what was probably just, intention a few years ago. Now it's a reality. And then we are working in what is going to be next. And then we are, CO2 Concrete is, is part of our R&D, I think now reality. And then also we are working in the biochar technology. Hopefully we will be able to have something combined in a project that we are working together. So very exciting. As I mentioned, EcoCycle is what is different is is recycle is recycled material that basically is verified by a third party by international ISO 14021. So it's validated a minimum basically to be able to have this label. Is minimum we have to have a minimum of 10% of construction demolition materials in the product. That could be aggregate, but also from the global we have cement and different products. Probably the last pillar is natural people, and that again is not only about product precast, and our Humes division is doing very exciting initiatives with with filter that are able really to, or system that are able really to capture the the water from the soil and then filter, and then that's is now available. We have in concrete, that probably this is my area as well, Iromedia is a product that also is available in shore. Is basically it's a no fines concrete that is able really to ensure that the water is coming through the surface, because concrete is great, but obviously we need permeable surface, in particular, with these flooding issues that we have been facing in the last few years. That is also a solution, is available as well. So we are working in in new initiatives, and great to be part of this journey. So just to regard, is basically Holcim is leading all the sustainability initiatives that are happening in Australia, and then we already have solutions for for road base basement application to to the infrastructure and the building. And that is our journey, and that's really exciting to be part of that. That's pretty much what I wanted to share with you all, Holcim. So thank you so much.
The center is Ms. Saji Srivelan.
Hello, everyone. My name's Saji. I work for John Holmes. I started with John Holland a few years ago as a graduate of chemical engineering. Now, when I started in chemical engineering, I interviewed for the role. They sort of said, oh, there's not really a role for you here. We're construction. However, sustainability started building. So I said, I can do that. You show me how. So I think the biggest thing I want to take away of this presentation is you don't know if you don't try. My journey in waste sort of started with my final year project, which was around lithium capture from wastewater, which is what started me prompting how else can we use waste products. I think the really exciting thing about John Holland, which is a tier 1 construction company, so we'll operate across Australia as well as in New Zealand, is our key values are caring, empowering, imaginative, and future focused. So I think having a company that backs you like that enables you to do things with innovation. So something that I did when I actually moved up to Sydney for the current project I'm on from Melbourne. When I was in Melbourne though, how Vivian and I met was I actually heard a podcast that she was on. It's called Climate Conversations with UTS. So from an idea, we've taken that all the way into practice, which shows you that the more times you speak about innovative products, sustainable materials, and other things that are coming up, the industry does adopt it. They do want to trial it. There is appetite, as Lourdes says, for sustainability and moving forward. So I didn't have much more to say on that, but thank you all for coming. Vivian, thank you for inviting us, and looking forward to chatting to you all about concrete.
Next, we invite the panel members for a panel discussion. Professor Vivian Tam, Mrs. Lourdes Sanchez and Ms. Saji Srivelan. Questions, please.
The question that you know what the low if I'm the so that I'm band like has this it's here to create by sap 5 blocks. Oh wait, yes. Nitpick the spine blocks at the I'm namataya the blocks should be used when we do guidance. Yeah. If I can know how that yeah, I am and the that I see the ceilings but I'm not be fuck. That's ice. No, well, non is not necessarily because CO2 concrete is a technology, and the technology basically gives us the chance to use higher content of recycle into concrete applications. So any application. So at the moment, as Vivian mentioned, we have experience in driveways and footpath and some low risk application. But what we try to our next challenge actually is a 40 MPA in a big infrastructure project. So what that is not necessarily replace anything. Is what we try to have is concrete, conventional concrete for different applications that basically give us the same or even better performance that concrete produced with conventional aggregate. Well, typically this is for basically to, from the structure point of view, that's basically to have lighter, slab. But yeah, it's definitely, there is a very good application for, for the housing industry, basically, instead of to be using the conventional 20 or 25 NPA concrete to use CO2 concrete that is also is going to meet these 2020 AFI MPA properties.
Okay, we do have a PhD student working on the thermal properties at the moment to see how it's performing the high temperature. In terms of research, I think I mentioned that we've done that for the last 10 years. We've done majority of the mechanical performance and maybe a bit of like durability performance before, but recently we are targeting on structurals and also the fire performance, and also looking into how can we move further. If you can see that my PowerPoint is we actually, in the last couple of years, we start doing the commercialization pour to see exactly how that's to the scale. That's why we're slowly moving it. And we're slowly moving the percentage increase and see how that concrete perform. But we're also looking in terms of the performance. Well, like from 25 MPa, we're targeting on 40 MPa. We may be also looking to other applications, but the slowly way to ensure that because we understand that if the technology is moving way too fast, maybe we didn't have enough time to react and reflect. And that's why we try to move it in a reasonable pace to ensure that the progress and practice can be aligned on that as well. 100%. Yeah. Maybe the next poll is 100%.
Has it? And I just want to ask because before I'm currently a kitchen student at stuff, but before my research, I was working as a quantity engineer. So I'm really interested at whether it has potential to be fixed the building cost, maybe so the house for the
I mean, my first degree was in quantity surveying as well. That's why I'm very targeting in terms of how that whatever innovation, whatever products that you need has to be a bit of a money figures in terms of the reflect what my background is. You come a little bit late. I think I have a slide that's showing that CO2 concrete is about 10% cost reduction compared to virgin concrete. And that is, I think one thing is important, but also carbon and other thing else as well.
I think that's exactly the thing. Like, if the cost reduces, then everyone will use it, and therefore you get a better carbon reduction. So I probably just agree with what you've said. You covered 5 points.
Yeah, well, from the concrete, supplier point of view, I have to mention as well that depends on the application, that could be probably not exactly, a cost reduction because there is some challenges, there is some cementitious penalties if you want to meet the same performance. Sometimes we have to increase the binder content. I think that is going to be our limitation because obviously if we're increasing cementitious, then we are going to increase embodied carbon. So we need to find the balance. But yeah, the goal, and we discussed before that we need to find solutions that really are also, there is some potential cost reduction because it makes no sense to be working in initiatives that are fantastic in in the lab, for example, or in a paper, but or we are not able to to produce and in a big scale. I'm talking about in a concrete plant. That this is one of the challenges when we are talking about innovation or new materials. And then also from the cost perspective, need to be something that, is no expensive and is basically for a few cubes and that's it. So this is, I think this is where CO2 concrete is definitely aligned to all these initiatives. So yeah.
Any questions online, apparently? In more questions? I've got a question. This is just a kind of hypothetical question. If we meet again in 10 years' time, what would success look like for circular construction materials in Australia? And what changes would you hope to see in the built-in environment?
Okay. Well, this is a very good question. Probably success, in my opinion, will be we are considering now CO2 concrete or the usage of recycled or low carbon solution as before. So that is not going to be different or innovation, or it's going to be, normal business, let's say. What we have to do is, we have to do a lot of things because even probably we are talking about big infrastructure. I can see that obviously, everything is moving much bigger. But if we go to even, some small council, still consider that, low carbon solution is green concrete. So it's different color or something different. And it's, I think the big infrastructure is leading the change with not only with low carbon solution, it's with different innovative solution, but there is still, I think, a lot to do if we want to consider that now this is low carbon solution or a recycled material is the baseline. So, and then we have to focus in what we want next and what else we can do basically to, to reduce not only the carbon footprint is in particular reuse our waste. That this is one of the main challenges that I think we are facing at the moment.
I really like this question, actually. I think to your point on cost for a contractor, our ideal would be that when we knock down a building, we can give that to somebody they can use those aggregates and give us back concrete that we can use to reduce our costs. So we're not just purchasing virgin material all the time. So I think in 10 years' time, if we looked at success, it'd be one, fewer landfills, because all those landfills would just use as stockpiles to service the materials industry. The second thing for us would be to have modeled before we even started building what materials we had that we were going to take down and where it could go. And thirdly, it would be to reduce our costs, because that's all the taxpayers' dollars, right? So if we can bid at a lower cost as well, that's better outcome. That's more money to go into other things as well, including R&D to improve our waste segregation and waste technology to improve our circular outcomes. So really for us, it's to build a circular economy in 10 years. Like we have the research now, like it really shouldn't be too hard.
Probably add a little bit of that. CO2 concrete has worked in the lab for 10 years. In the next 10 years, I really want to be able to see the product be able to sell on demand. Probably that's why we really need the partnership with the partners in here, because I am not going to open a startup to just sell the concrete myself, because that's really impossible from my perspective. But I think going through that pathway is very important for us or the public to ensure that we accept the sustainability. We accept that waste can be a resource that is matching with the original product as well, because I personally have a slogan of turning waste as resources. I feel like that a lot of us may feel a little bit hard to accept it, particularly when you have different kind of products. I used to have a phone case that they are recycled shells, which has nothing wrong with it. And they are also as strong as any other brand that you will have, like a drop proof, that kind of thing. There's nothing wrong with it. It's just recycled materials. Well, if you tell them that it's recycled materials, you might, I would think about that kind of thing, and then look in the course and different perspective as well. But at the end of the day, I want 10 years time, people will not put that perspective there, because we want to ensure that waste can also be resources, ensure that accepting those. I think the culture is slowly changing. I have to say that if I can give examples of the first concrete pour in 2022, the concrete suppliers that was coming to pour the first CO2 concrete. And obviously, we have a whole crews coming on the stage, which is like breaking the concrete up a little bit. And then they were asking us, what you guys are doing? And then because the pour next, or which is from another company, why like normal, but we are here coming with like 10, 20 people all over interstates as well. And then we just said, oh, we are pouring innovation concrete. And then the concrete said, oh, I don't know anything innovation at all. I just want something basic. I have to say, 1 year later, we poured the second pour in the Emerson Park. The same concreter actually put his hands up. He said, I want to witness this again. That's why he put his hands up to come and pour the second pour of concrete. I think that is the perceptions that I really wanted to be changed. And it's changing, I have to say. And obviously, slowly, I want like more and more people to able to accept this kind of concept as well.
It's a cook on Hodgel. If you were to scale production of this, like on a really commercial level, what the existing infrastructure that you have, does that work or does it need changing?
In the laboratory, no, it has to be in production, yeah.
For a few things. Can you hear me?
That is working. If it your best.
Hello. Well, I think a few things need to happen because Vivian basically explained the capacity that we have available now, basically to produce to treat the aggregates. Okay, we have some limitation to produce X ton of recycled aggregate per month. And that is going to be one limitation. And the other challenge that we always had, as I mentioned before, is obviously we need to have a dedicated stockpile for the recycled aggregate. But that is going to be based on, if there is a project, we are easily able really to adapt our plants basically to accommodate to these materials, because this is what we are doing at the moment. Probably the only big risk, and it's no with when we are talking about recycled aggregate, typically when we have to add, manual handling for in bags or something, that is a challenge and there is a safety risk associated to that. But when we are talking about recycled aggregates, we have all stockpiles or a dedicated bin basically to, to have the aggregate. So that is probably the only limitation to be able to supply, is to have enough source to produce the CO2 concrete, and then in production to ensure that we have capacity to accommodate that.
I have one more question. It's about the sustainability. Our thought leadership is on that. Okay. Is the construction industry moving quickly enough to meet climate targets? Or are we still treating sustainable materials as optional innovations rather than essential infrastructure solutions?
I can go there. Yeah. My view is, I think it's still considered as an innovation. I think that's no in particular in Australia, but obviously when we are checking what's going on around the world, I think Australia in this space is a little bit behind. Probably Vivian can give us a little bit of view, as he has been in Europe last few weeks. But yeah, we back to to Europe. That this is where I come from. And recycle is available, and actually is we have regulation, and is actually mandatory in some of the countries, as Belgium or Netherlands, for more than 50 years. So we are not talking about yesterday. We have plenty of experience, and the regulation, I think Vivian mentioned that the regulation in Europe consider recycle and recycle aggregate for more than 20 years now, and consider that if you replace minimum, because depends on the country, minimum 20% of your coarse aggregate recycle aggregate, your concrete performance is identical. And that is what the current regulation includes. So what I can see here in Australia, that's at the moment is this kind of initiative that customers that really want to push boundaries, or we have also some in some of the projects is included in the specification that's minimum use or even manufactured sand. I come from Europe. Manufacturing, there is no manufactured sand. It's just sand from from a quarry. So the first reference that was a little bit shocking is what manufactured sand is. So this kind of initiatives that we have a lot of experience around the world should be available in Australia, and then that will be probably give us the chance to to move a little bit faster, because I have the feeling at the moment that, as I mentioned, is a big infrastructure is moving a little bit faster because there is, there is a specification that include the usage of these kind of materials, but there is other application that basically even, if you are talking about the usage of supplementary cementitious material, is a big deal. So there is nothing consistent. So this is the view from the industry. I think still there is a lot to do.
I think though that's an interesting point though, just in terms of sustainable materials, it's not the only solution, right? I think the biggest thing about the CO2 concrete is that introduction of the negative emissions technology, which a lot of materials at the moment aren't actually doing. So I think the project that us three are partnering on, what a key outcome of that project is to develop this concrete, test it on our project, but then give it to the client to register it on their materials register so that all projects can use it. So we can scale up things like this. So then the entire industry, not just John Holland, not just, whichever company, not just Holcim, etc., we're all using it. So we're transitioning to net zero. I think with the legislation in terms of net zero targets, it has really pushed the industry a long way. But the challenge is it's not just substituting out for like cementitious materials and things. It's also the manufacturing process in itself to create concrete, right? So you need to have like renewable energy to power all your manufacturing plants and all of that. Us as John Holland, all our plant needs to be either electric or powered by renewable sources, or none of us will get to net zero really. So I think there's a long way to go. Sustainable materials are our biggest emissions impact. However, it is only just one part of the story. Just implementing the material is not enough.
Maybe I don't have much to add, but I might be using this opportunity to also introduce Nobel. Nobel is our, sorry, it's a bit of a promotion, I think allows. Yeah, it's our ARC Industrial Transformation Training Center, which is targeting on digital platform for net zero building ecosystem. You can imagine the title if you wanted achieving net zero by life cycle perspective, also using a digital platform. And Holcim and John Holland will be part of the partners in the Nobel, and we also have a lot of partners as well, which we have been showcasing outside during this week conference. What is the perspective of that is there are 5 main programs. Industrialization, resilience, digitalization, decarbonization, and the last one is the integration. Material is one of the components to help achieving a net zero. But we have other components. Knowing other components also all together to make it happen as well. That's why I want to highlight that is all of us need to be able to try to help a little bit to achieve the net zero or sustainability, but has to be really in a joint venture of approach to be able to achieve that as well. Yeah.
Thank you so much. Any more questions online? Anything? No. Any more questions? No. Then guess thank you so much. Thank you, Professor Vivian Tam, Mrs. Lourdes Sanchez, and Ms. Saji Srivelan. Thanks for your time. And thank you everybody for attending. And please have some snacks and some drinks, okay? Because we got it from the library. Thank you.